What is going on, guys? Welcome to the beginning of what is another new pretty big horsepower build that we're going to be doing on the channel. Now, we're not doing the entire car because that's what sort of we're trying to get away from, but we are sorting out the engine for him. We'll probably be wiring up the car as well as obviously tuning it, but he's had the box built elsewhere. He ordered a rear end from, I think, Castlemaine. He's ordered a new front end for the car as well. Most of the turbo setup's already built. We're just putting a different turbo on the setup, but it should be capable of what we want to do, so we shouldn't have to change that too much. So we're being very involved in the build, but we're not doing the full build. But anyway, I can't actually remember if I even started a video on this engine, to be honest. But this is another LY6 Gen 4 iron import block from our boy Luke there at Sohem Custom and Supply. So huge thanks for Luke at Sohem. We've pretty much been getting all of our iron blocks and imports from him lately. So it's been really good having that hookup. It's been really good being able to get these iron blocks. And he's just moved shop to a bigger shop, so he's just getting more and more containers through. So it's a pretty steady supply these days. So yeah, so much better and works out cheaper than trying to get Australian delivered LS variants. But anyway, so we're starting with a LY6 iron 6-litre block. We've got here a spool 4-inch crank. We've got ourselves a set of spool drag pro I-beam rods. So, you know, these rods very much, you know, good for a lot of power. You know, people put these in 2Js and stuff like that and then make, you know, well north of 4 figures on 6 rods. So, you know, for 8 of them, we should be good. And then we've got ourselves a set of CP bullet pistons, all supplied by Spool. So a big thanks to Spool there for supplying those. Today I've just dummy assembled the crank and rods with some stock pistons in the block because it hasn't been bored or honed or anything yet. Just to check the clearance of the rod shoulders on the 4-inch crank, because that is something you do have to be careful of, because often on a 4-inch crank the rod shoulders will actually contact around the block on the skirts and stuff like that on the bottom of the bores. So just checked all that clearance, but that all came back pretty good. So this thing's pretty much ready to go to the machine shop now. So a little bit of extra stuff going on this thing with machining. You know, generally always ARP hardware, line hone, torque plate, bore and hone, all the rest of the berries. But this one also will be getting some fire rings. So that's how far we're going with this one, is we're actually going to fire rings. As well as a Torrington thrust bearing. So this is going to be in front of a Turbo 400 that is going to be 2,000 horsepower rated. It's built by Craig's Automatics, so 2,000 horsepower Craig's Automatic built Turbo 400. Now, when you go to this sort of caliber of gearbox and car, you end up with huge line pressures, and what huge line pressures can do is push the converter really hard into the back of the crank. And what you can actually get is your traditional thrust bearing, because of the pressure from the gearbox on the back of the crank, it does start to just eat them and prematurely wear them pretty bad. It is a pretty common thing. So what we do, or what we get done, is a full 360-degree Torrington thrust bearing, which gets machined into the back of the front cap and into the front of the first counterweight on the crank, which just allows or supports that extra force on the back of the crank a lot better, and obviously allows these engines to live a lot more at those sorts of line pressures in the gearbox and that. So this will end up with a G45 1500 on it. So yeah, you end up around 402 to 404 cubic inch. So yeah, it's going to be a bit of an animal. We're hoping to make around 1,200, around 1,100 wheel to 1,200 wheel, hub I should say, is what we're aiming for with this thing. So yeah, basically trying to overbuild a fair bit. The biggest thing with what we're doing is we are still just using a factory GM block, which is only 4 bolt. And what I mean by that is you've only got 4 head bolts surrounding each pot. And with what we're going on here, basically the limit is going to be, you can only get so far with these things before they start to lift heads. So that's why LS Next blocks, Dart LS Next blocks, and you know, the heads to suit those, they actually have six bolt heads, but they actually have extra head bolts and heads for head studs, which just holds everything down a lot more. But being that we're using factory block and factory heads, which have been already CNC ported by our boys there at Tremaniac or Next Gen Engineering, so a huge thank you to those boys. But yeah, that's the limit of this at the moment, is basically, that's why we're going to fire rings, to do our best to try and keep the cylinder pressure in the cylinder. But yeah, there's going to be a lot of coolant pressure sensors and that sort of thing going on when it gets wired up, so that we can monitor whether we're pushing any of that cylinder pressure out into the coolant passages. But that's going to be the biggest limit with this thing. But yeah, you know, 1,200 horsepower should be pretty right with fire rings. We should be pretty happy around there, and that's what we're shooting for with this thing. So, yeehaw. Anyway, I'll get this loaded up and get it down to the machine shop. They can start machining process with all the stuff we got to get done. and we'll get it back here and start getting this thing back together, which will be good fun. So we'll pick it up then. Yeehaw. Righto, boys and girls, getting all of the spice out, getting ready to get started on this iron block. Now, there's been quite a few changes that have happened in the process of basically since we started with this, pulling it down and getting it to the machine shop. So we're not going turbo anymore. Trav ended up picking up what I like to call a grown man blower. So it's going blown now, big blower. The power goals are still pretty much the same. So the engine combo still pretty much remains the same. We've made a few changes just to what valve springs and hardware we're using for the valve train. Nothing to do with the blower change. That is just some new information that we learnt in the meantime with some other engines. So Bo's starting to set up our next gen Tremaniac CNC ported heads. As you can see, we've got our spool 4-inch crank over there, ready for me to start taking some measurements. You can see it has been machined for a Torrington thrust. Working with our machine shop at a point now where really easy and cheap for us to get that done now with them. So it's been a bit of a long road getting that sorted, finding the right parts, finding the right processes and getting it right. But this engine here, which you'd be able to see on a different video, also Torrington thrust, just much safer, much nicer piece. And obviously the gearbox builder specifically specified that this engine needs to have a Torrington thrust. So starting to get this together. Bo's going to set up our valve springs, check installed heights, do all the rest of that while I start assembling some pistons and rods, getting some stuff together. Unfortunately, at the moment, we don't have a spare engine stand, but as you can see, there's a bit happening here, and there's another 2 complete engines just outside on stands. So Bo's checking installed heights, working out what shims we need to get these sorted. I'm giving all our brand new parts a bit of a bubble bath. Looking red hot. All nice and washed. We'll give them a blow down and we'll start looking at doing a few things. Bo the gun has assembled our heads with the correct shims to get our installed heights all right. Looking good. So yeah, we're using a TI retainer with a hardened lock and a slightly higher spring pressure than we were originally intending to run. It's just going to be a bit better suited to the combo. But man, I'm a huge fan of these Tremaniac heads. And I've got our nice little tack weld on our reluctor wheels so it can't spin or go anywhere. Rightio, crank's all bottle brushed and cleaned up. Back here this morning, continuing on with this, doing some more checks. Bo's doing a heap of CHE kits for us. Got a lot to go on. But this crank is going to have to go back to the machine shop at this stage, unfortunately. So when we sourced these Torrington bearings and started working with this machine shop and trying to figure out how we were going to go about this and get this done, we sourced obviously 2 bearings for the 2 engines. Now what I believe has happened is I think they've used the same bearing to machine both cranks, and I believe that potentially this bearing is maybe just a little bit tighter, but for whatever reason I cannot get it to seat where it's meant to on the crank properly. The internal diameter where they've machined it on the crank is too big. The bearing won't seat. I've tried a few different methods. Obviously at this stage, I tried to put the main cap on with the crank in there with the bearing and just sort of hit the back of the crank with a rubber mallet like you would to set your caps, just to try and get that bearing to seat properly, and it will not seat. So unfortunately it's still 20 thou. I can still fit a 20 thou feeler gauge in this side. I don't know where I put them. Oh, there it is there. So that's a 19 thou feeler gauge, and it will still go down there. So that's no good. But as well as that, seeing as the crank's going to have to go back to the machine shop anyway to have this sorted out, they're going to have to take a little bit more of the internal diameter off that crank. From doing that one, I had to take so much. Sorry, I should start this for prefacing. The way that he machined it in the crank was he used a set of old bearings that he had in the machine shop to dummy it together and set it so that the Torrington face contacted that front main and was tight on the front face of the regular thrust bearing. So basically it was just a tight fit. But what I found with that is I think the bearings, whatever he was using, must have had a slightly smaller thrust on the front, or might have been slightly worn, or something was going on. But I had to take so much off the front of the thrust bearing on that engine to get our end float. Like for us, it was actually like almost interference fit, and the amount I had to take off the front of that thrust bearing to get the end float was pretty wild. That was quite a bit we had to take off. So what I found fitting this is, you know, with the Torrington up against the front where it's meant to be running, I only had 12 thou of end float before this
second counterweight actually contacted number 2 main webbing, which means I only had 12 thou without the standard thrust bearing in there. So at 12 thou with no thrust bearing, the amount of material I'm going to have to take off the front of that thrust face is going to be pretty huge. But that being said, obviously I can still fit a 20 thou feeler gauge in down between the actual thrust bearing and the crank. So if that takes up that whole 20 thou when the bearing's on there properly, that 12 thou is going to turn into 32 thou, which is probably going to be a bit more acceptable. So it's a bit hard to know whether to get him to take more material off the front of the crank and allow that bearing to come back on the crank a bit further, or whether to wait and see how it goes with that bearing seated properly. But it's a hard one because I don't want to have to take too much material off the front face of the thrust bearing, but also I don't want it to be contacting the standard thrust before it contacts on the Torrington thrust. I sort of really want them to be both contacting almost at the same time, so that, you know, this is taking the brunt of the force and this is still sort of doing its job or its intended purpose, and still using or taking a bit of that thrust force. So it is a bit of a difficult one. Probably the best way to go is probably just to take the block, bearings and crank all back down with me, the bearings that we're actually going to be using, and we'll put them all in, dummy it all up, and probably just have to machine it on the day, try and get it right. But yeah, lesson learned. So basically source the thrust bearing, and the thrust bearing has to stay with its crank, machine the crank for the thrust bearing, and that thrust bearing belongs to that crank, much like a ring and a bore sort of thing, because obviously they are slightly different. Because we did not have the same issue with this one. This one sort of went on fine. Nice little bit of a looser fit. You know, it doesn't need to be an interference fit. Being a little bit loose is not going to bother it at all. That's not how it does its job. It doesn't need to be an interference fit. So anyway, frustrating. Frustrating at the moment because normally I'd just chuck it in the car and I'd bounce now and I'd be down there in 2 hours and we'd be having this sorted this afternoon. But obviously after being diagnosed with epilepsy and not being allowed to drive for 6 months, I cannot drive, which so it's no longer up to me, and it's a long way to go. You know, it's a 2-hour trip down there and then a 2-hour trip back, so it's a half-day round trip and probably a whole day by the time we're down there actually machining. And I can't take myself, which means I have to take, someone else has to take me, which means that, you know, 2 of us lose a day to get this sorted, which is incredibly costly for us as a small business. But anyway, electric ring filer, what up? Yeehaw. Rightio guys, so just got done doing our big end clearances. I spent a lot of time bearing fishing and just sort of getting this all right with the crank to get every single one of our clearances is between 2.5 to 2.6 thou. Most of them are 2.5, some 2.6, so very, very close. This crank's really good. Really happy with this crank, the way everything came up. So now that I'm happy with the big ends, now I'll get the engraver and I'll start engraving the rods and caps now. So I spent a lot of time trying to get them all exactly right, and they are right before this crank goes, because now I can, yeah, engrave these rods, number them, then I can start putting them together with some pistons. We'll get the scales out. So as you can see, our rings are gapped, so I can have our pistons, rods, rings, everything assembled, ready to go. And then when the crank and block gets back from the machine shop, all I need to do is our main bearings, set our end float, and then we can start smacking this bottom end together. But yes, there was a lot of time swapping things around and fishing and getting it right. As expected, pistons all weigh the same. Our machine shop there at SPAE are absolute G's and already balanced them. So always good to double check all of that. As you can see, we're all engraved, ready to bloody go. All dressed up, rings on, ready to go together when we get it all back. So that's it for now. Send it back to machine shop. We'll see it back when it's all finished and sorted again. Get it together. So you can see with these factory castings, these blocks, these castings around these holes, they're just rough as guts. Like that big dag there, that just, you know, that's not necessary. That doesn't need to be there. So you can see I've just finished cleaning this one up just with the burr there. I'll still get into it with the flappy wheel before we finish off and just smooth it out, but that's all I'm trying to do is just all of these gross big dags that don't need to be there. You can see how rough the casting edges are, so we just like to spend a bit of time cleaning those up. Same there, just huge big dags, big sharp edges, just doesn't need to be like that. Clean it up nice, spend a bit of time. Just hopefully there's a bit of appreciation that
it's hard to show it on YouTube videos and through content and stuff, but there is just so much time that goes into building engines.
Alright, we've got DOD towers all plugged. You can see how much nicer all this looks after it's been cleaned up. Yeah. Alright guys, so this is what we will be using instead of this now. Well, obviously this engine, like I said, still going to get built. It will be for sale, but this is what we're now using. Full Dart LS Next Pro block. As you can see, 6-bolt. We'll start pulling it down. I'll show you what's inside it as we pull it apart, but we do trust that it's been put together properly, but we do have to pull the crank out and get it machined for a Torrington thrust, because they didn't build it with the Torrington thrust and we still need one for the gearbox. So it's got to come apart anyway, so we'll show you what's in it. We'll check it all as it goes back together, just so that we have peace of mind and know that it's right, with everything being double checked as it goes back together. But as you can see, full dry sump, Velocity Engineering dry sump setup, so we'll have to get a pump and do all that as well. So it'll be fully dry sumped. And yeah, BR7 Brodix LS7 heads on the way from Tremaniac Racing, so they'll be full CNC ported. 6-bolt LS7 heads, and yeah, get all this sorted out. So yeah, be a bit of a step up from the old LY6. But yeah, should be an animal. It does already have a camshaft in it as well. No idea what it is. We'll check it as it comes out, but we do plan on getting basically a full custom ground cam for this to suit exactly what we want to do, being that it is, you know, LS7, bigger valves, bigger ports, also 1.8 ratio rockers instead of 1.7, so quite a few differences in the valve train going from the LS3 to LS7 style. So yeah, we'll get a cam sorted to suit exactly what we want to do. Alright, there we are guys, Oliver rods. Looking good. There you are. So you can see they actually tigged up all the parts that weren't needed. That one and that one, so they tigged them up. So that's why this thing has to be dry sumped. It can't be wet sumped anymore because of they actually tigged up on the block, which is not a big deal. Obviously dry sump's great, it's just that this thing being a street car, not so much a burnout car or anything, it's not 100% necessary. It wasn't completely necessary for this car, but it is still a great thing obviously to have. It's just extra money that didn't particularly need to be spent, but considering what the owner's going to now, how far this has gone, you know, what's the cost of a dry sump pump and stuff. I mean, that's a lot of the cost right there, is the actual pan which came with the engine. So alright guys, so a few checks. We've got a Warspeed Wasp by Warspeed in Kelford. So it's one of Troy Worsley's custom ground cams in this thing, and just from a quick glance it looks like it's going to be quite good for what we want to do. So we may actually be able to use this cam. We've still got to do a bit further research and get the exact specs, but from an initial just look, looks pretty good. Now the engine came with a single row timing set on it. From what I can tell, I think that Troy Wars actually supplied most of the parts, or all of the parts that are in this engine. Now the reason so many people prefer a single row is because people don't do double rows properly, which is what I'm doing at the moment. And if you don't need to, obviously, you just go to a single row. It solves this problem that I'm just about to show you. But the issue with going dual row, which you don't particularly have with a single row, is what I've done here is set up the dual row gears on the crank and the cam, and that's sort of sat all the way back in the receiver on the cam. And if we put a straight edge across the, hang on, I'll just switch hands here, make it easier for me to show you. Straight edge across the bottom gear, you can see the gap there between the straight edge and the top gear, which means that the chain is not going to be aligned properly, and it's always going to be running a little bit out of alignment. And this is why we check these things. You know, it's not as if Troy Worsley and all these other really, you know, the best LS engine builders in the world, it's not like they don't use dual rows. It's just that they check these things, and you need to get the front of the crank machine so that the gear will actually sit back properly and actually align the chain properly. So this is a problem with dual row kits. Obviously with single row kits you don't necessarily have this problem because of the offset of the actual gear, and there's a bit more room for the actual gear to just settle where it needs to on the crank and not move around. But with the dual row, that's sort of where it has to sit, and it's already too far out for the cam. So seeing as we have to send this block and the crank away anyway to get the crank and block and cap machined for the Torrington thrust, I figured I'd measure this before it goes so that I can tell our machinist, hey, I'll measure this up, find out exactly how much further out it is, get our machinist to take that much off the face of the crank while he's got it there. That way when we get it back, we can run a dual row, it will be properly aligned. It's the way you should be doing your dual rows, and it's all happy days. So But yeah, it looks like this cam might be really good. Obviously, Worsley knows exactly what he's doing, and it's one of his cams. I believe, looking at the specs as a quick look, it's going to be pretty good for what we want to do. So we might end up just using that cam and not getting a custom one ground. But yeah, so far this thing's looking awesome. I'll get this sorted out before I continue to pull it down, and then once I know what I'm doing here, how much to take off that, I can pull the cam out, pull the rods, pistons, get the crank out, get it ready to go down the machine shop. Alright, so the next drama is if you take that bit of meat off and then you push this back, you can see the rivets on the chain there will actually be running. If I took as much as I know I need to take off the front of the crank, the chain's going to start running on that front face of the crank there. So I will send the gear and the chain down to the machine shop so we can check it, but that chamfer on the front face there of that part of the crank should just need to be chamfered down a little bit. There's a fair bit of room back to the bearing. There's a fair bit of room to continue the chamfer, and I don't want to take anything off the actual face because I don't want to do any changing to the radius that's there on the front of the crank, because once you start affecting that radius, that's when you start to really affect the structural integrity of the crank there. So I want to leave the radius alone. Let's get him to chamfer that. I'm sure he'll know what he's on about. So at this stage it's 0.9 mil. I wanted to get him to take off the front to align the gears properly, which means I just have to take a little bit more of a chamfer to ensure the chain doesn't run against it and grind on it and start eating it away. Alright guys, so I guess the first concerning thing I've found so far is the size of the wrist pin that they've used to put this together. It's an awfully small wrist pin. This is just for contrast the wrist pins that are going into the LY6 400 cube stroker. So this is the size of the wrist pins we've got for that combo, for, you know, a heavy boosted setup. And that is the size of the wrist pin they've used for this combo. So, yeah, bit of a worry. Might ask a few people a few different opinions and things, but righto guys, so we're pulled down, basically ready to go to the machine shop. So what we thought originally was going to be just a simple machine for Torrington thrust and put it back together isn't going to be the case, for the fact that we definitely do need to change those wrist pins. Did plenty of research, I tried to find plenty of information. Turns out those ones, the little baby ones, are a chromoly 5100, and the ones that we're using for this are like a different type of steel, a 9310 or something, 9320, whatever they are. But either way, these are a harder material as well as being thicker. So the chromoly ones that are in that, they're not only are they way thinner, they're like a real entry-level wrist pin. So honestly, it doesn't make any sense to me as to why they're in this combination at all. Not sure, but I guess that's what happens when you buy second-hand stuff. There's always that risk. So the crank is 4340, which is you know, listed by everybody as a dart billet, 4340 billet crank. So you know, everything else is what it was meant to be, what it was stated to be. Apart from just the block mix-up, and everything else is still all good. Just that we're definitely going to need to change the wrist pins, which means that we are going to have to rebalance. And given the fact that we're adding material to the bob weight, it's probably going to mean more Mallory in the crank. Given that that's got those wrist pins in it, a few of the things I'm looking at on the crank, and the rods as well, and the pistons, I can't see anywhere any material has been taken out of any pistons or anything like that. Yeah, I think it's probably not a bad idea to have this rebalanced anyway. So we'll send the other flex plate that was sent with the Craig's gearbox with it. We'll have to get him another balancer to send down there as well as some new pins, and we'll get it all rebalanced for the new weights. And yeah, hopefully we come back all good. Not only that, we'll send the dual row kit. I've got it listed there how much to take off this face, and then obviously just a little bit more of that chamfer off just to stop the chain from running on that. And yeah, Torrington thrust, just like this crank here. Same with the block. And I'll get it all back and go. So, happy days. This TCR flex plate, I suppose, could probably go with the other engine when it gets sold. I'd just like to keep the other flex plate with this engine because it is the one that was sent by Craig's that they would like to see used with the gearbox and converter combo. So, we'll use that as it's their recommendation. Originally, when we were talking about just doing the Torrington thrust, we were hoping to have this machined. It's 2 weeks until we shut down for Christmas, so we're hoping to have that done before the Christmas break so we can have all this back to get this, basically the short, rebuilt over the Christmas break, so that was pretty much ready to go for heads and stuff at the start of next year. But now that we've got a fair bit more machine work to do, I don't think that's going to be the case. I don't think we're going to get it all. I don't expect the machine work to fit this all in before Christmas. Scotty there at SP was going to do us a solid and sort of
get the towing from thrust done before the shutdown so that we can get it to do it done, but I don't expect him to fit all of this in. He'll have his own stuff to deal with, so it's a bit more extensive than first thought. But anyway, I'm hoping by chance maybe it was just tossed together and not balanced, because it would make the balancing process on the crank a lot cheaper, because if we've got to put a heap of slugs of Mallory in there, it's going to start getting real expensive. But anyway, that's how it goes when you're building these sorts of engines, so let's see how it goes.